This is what we did last time. The quick revision of what we really covered last time. And we spoke last time about computational thinking. And we said it's a method of problem solving using computer. So the solution we create, it should be easy to translate to algorithm and to translate to program and use computer to solve it. And that's what we're focusing on here. And then there are 4 components of computational thinking. We spoke about abstract, you're looking at the data, and then, or the problem you're facing, and then start focusing on the areas that you need to focus on it and remove different things that are not really your focus for your solution. And then the compositions of the problem, breaking it down into smaller. We had that example of the image and we broke it down. It's a square, or so some patterns repeated, and then we wrote an algorithm and we did the code at the end. That we covered. We spoke about algorithm as step-by-step narrative of the solution that can be written using human language. And then we started in the coding. So far here was more concept, looking at it. Here we started in the coding, and we used Python, and we use a library in Python called Turtle. So we had the first line, import Turtle as T, and that means create an object of that turtle and call it T. And then we started giving instruction to that T. So go forward, go backward, rotate, and you did amazing work. All of you did amazing work, those who submitted, and I can see really getting the idea. Then we look at the loop. We said, you have a code here, 10 lines, we need to repeat it 200 times. What do we need to do? Then there's one technique called for loop, which allow you to have a variable here, anything, you call it I, you call it Z, you call it anything, and in range of 100. Now, the more details here, you can see range 100 means it goes from 1 to 100, but I can say range 50, 100. So you'll start by 50, then it goes 51, 52. So if I put 50, then that will fix where that range will start. And I can go backward as well by using minus. We'll come to that when it comes to this. So that's what basically we did. There are 6 things we covered last time, and this is summary of those 6 things we did last time. So today, what we need to do. Last time we had this code, which we had our import. We did speed it up. By the way, one of you, I think Susan or someone, managed to get to find code function called tracers and use that tracer to speed up more than 100, which is great. I'm really excited to see you looking at other things and going and reading. It's very clear you have been reading and going around and looking at solution, especially that link maybe I gave you. So this is a for loop that going for 200 times and starting going forward and continuing doing those things. Yeah, and continue doing that. So it produced that work. Now we have some question to ask ourselves now. First one, what if we need to have flexibility to decide or of deciding the length and the angle before drawing the shape? So we don't want to go always 100. Currently, we go and change this one to something else, 70, or this is 80 and go. We don't want to do that. If you have a long code, then it will be challenging every time you go and change this number and run it again. And I can see your solutions, even Steve, thank you for that great work, but repeating the code, copying the code and putting it down and changing the numbers and moving the place and doing like that. Is there an easier way we can do this without duplicating code and making our code is too long? That's one thing. The other thing, is there a way if we can repeat this thing without writing the code? If I want to draw another shape somewhere here, can I do that without copying this code down and changing taking the pin up and moving new position and down and then repeating the code? Is there a faster way to do it instead of printing that? I'm sure you you're thinking of something. And this thing which you're thinking about is called functions. Functions, basically, you group your code into functions. And then these functions, you can call it multiple times. And then that will simplify. So we'll talk about functions today. And that's the topic we're covering today. I'm sure if you want someone asking, okay, I'll come to those questions. Sorry for that. Okay, so function, what are really functions? Functions, as it's written here, is grouping your code in one thing and giving it one name. So when you call that name, that list of instructions in your code will be executed. So you have here in this example we had all this. If you put them all in one function and call that name of the function, it will run this one. Okay, so this is an example of a code of creating a game in Python. We're not going to do that today. Unfortunately, we're not going to create a game. But this is a code of a long code. I just grabbed part of it. I know you cannot read it. Yeah, that's good. I don't want you to read it. Now, but if you zoom in it and look at it, you look at this part of it. This is a function. This is the whole code is a function. It's a special function here. They call it constructor. So it's not the best one to look at it. But let's look at the other functions here. Here is a function here called def calculate gravity. This function this is a game where an object jumping in places and in different planet and different things, and the gravity keeps changing, depends on the places. So that's a function is being used. So it starts by def, there is space and there is a name for your function, and then a bracket here and some data can go inside. We'll come to that one in details. This is the next function. You can see another function for jump. And you can imagine now this jump in a game, how many times were executed? Every time the player jump, it jumps. So millions times during the game, it keeps jumping. So this function, you call it million times in the game. And every time you jump, you press up a row or you move the mouse or the cursor, it will jump up or jump down, depends on where you want it to do. Is there a jump down? I'm not sure if there's jump down, but jump up, yeah. And then this one going left, another function. So these are functions. So this code is broken down on smaller, manageable part of code that we can later reuse by calling jump million times. Every time something happens, that function will start. Okay, so each function is given a name, and you see here, they all have a name. This is jump, and this is calculate gravity. Now this name, and that's something sometimes my students get confused about it. This name is up to you. You decide whatever you want to call it, but you need to stick to that name. If you call it jump, when you call it somewhere else, call it jump. If you use uppercase, call it uppercase. If you use lowercase, call it lowercase. The way you declare it here, you call it there. And we'll come to that one in details. So each function is given a name that does not include a space. There is no space in the name or special character. You can use underscore, but you cannot use minus or percentage or question mark on those things here. And doesn't start with the number. So these are the things you need to keep in mind when you create the function. No spacing allowed in that function. Some function will require data to run and do the calculation or whatever. You need to pass a data to that function. Give it the data. See when you're searching for a student ID, your student information, and you have a function called student, find student information. You need to pass to that function the student ID. So it will go to the database and find who is that student. So that function required to have data. Their function do not require to have data. They just find the data themselves. It depends on the way you design your functions and how you want to do that. Some function return data as well. After doing calculation, return back to you some data, and some of them do the process, display it on screen, or do something. Like for example, that jump one. What basically it will do, just push that object up by certain height or angle as well, depends on that function. So functions are reusable blocks of code. So that's, you put your code in groups and allow you to reuse it by just calling the name. And we will see example today and we will work on that. So when do we need to write our code as a function? So I have for you a question here. I want your phone again to come back and answer this question for me. I have a question here, and this page, it should be, the question should come here. Okay, are you there? These are you, but in, you know who is the, okay. Okay, so getting ready. Just get, I can see how many of you, the only 18. Okay, I will start the countdown as soon you are all here. Most of you here. I'm going to jump, so those 23 will be able to answer the questions. You look very nice on the screen. Your faces are looking beautiful. Okay, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have around 58, but not everyone is here. Getting ready. Now you'll get a question and you need to answer the question. The first one who answered the question correct will get a point. When do we need to write our code as functions? Select the correct answer. I'm not showing you the, okay, here is what we have. The answer is to manage large code and when we need to reuse our code. And I can see there are 20 of people went here and 18 went here. Okay, who's the winner? The winner is Geeta. Geeta in the first place, Rare in the second place, Muhammad, Anis, and then goes on. Good, thank you for that. Let's go back. So when we really want to manage our code and divide it into smaller components to be able to manage it and to use the code. Now there's one about testing code. That's another one also can be used during the testing. You can. Okay, structure of a function. Let's go now and look at how we create a function and how we structure that function. You have seen from the examples we did, is the first thing you need to have is the word def, D-E-F. That's defining a function. This is different from other languages like Java, JavaScript, C#, and other, but this is how Python does that, D-E-F. Then a space. The space is must. If you don't have space, then it's not considered a declaration of a function. Then you come with a name. This name is up to you to decide on it. Given that it doesn't start by number, it doesn't have space in it, and you're not using some special characters that used for calculations or for something else. So that's the name. It's up to you to decide that name. Then you get a bracket here, and if the new data is going to that function, you just open and close that bracket like what we have here, and colon there. So that's opening it and just closing the bracket. And then if you're passing data, like we're passing the length and the angle of that shape you want to draw, then you have here two variables to add. One for the length, one for the angle. Again, this is completely up to you. You call it whatever. You want to call it X, A, L, angle, call it whatever you want to do, but follow the same principle that you don't have to start by number. There's no space in it. There's no special characters that been used here. Just letters and numbers. But you can start by, you must start by a number, and then you can add, by a letter, and then you can add a number if you want. But you cannot start by a number. Yeah, you must start by a letter, and then should be no space in that. Now, this colon is important. That tells this the code that belongs to this function is coming next. So this declaring the start of the body of your function. And this comes here, this is the body of our functions, which we have the same thing. We just brought back all our things. Now the next thing we need to do, change those 100 and make it L, and change 90 and make it angle, and this L, this angle, this L, angle. This way we go away from using fixed numbers to using variables, number that can change as we need to change. So this way we have a function called draw shape, and then we do what we did. And this is the change by using L angle, L angle, L angle. And we kept the last one because it has nothing to do with the L and angle. But again, later we will have an exercise how to include this one there. We will come to that. Good, so I want to use now this function. I created a function. How I can use it? You create it. If you just do that and run your code, nothing will come on the screen, because basically your function is created in the memory of the computer and you did not ask it to run. You just kept it there. So to run it, you come to using the function. This is how we calling a function or executing a function. Then just you use the name of the function, you open the bracket and pass a value for the first parameter and value for the second parameter. So our function here require L and angle. We come here, draw shape, we pass 100 for L, 90 for angle. Then we can run it again. These are data, name of the function, data. Now we can run it again. This is the draw angle, the same one. If I want to draw shape, if I want to run it again, I just add another line below that one. I say draw shape and pass different data and different angle. This way it will draw first the first one, complete that. And on top of that one, it will start drawing another one with different length and different angle. And I can run more of that. I can put another one and change the length to something else and do that. You can move your pin up and go to another place. Yeah, so you move pin up and then change the position, then pin down, and then you call the function. It will draw in another place. So no need to repeat the code. The code is done once for the function. Now we can call it as much as we want. And that's the way to make our code reusable. The one thing important in Python, as we mentioned last time, is the indentation, or this where your code should start, the next line, where it should start. You can see here, starting from up, this is 0. And this is 1, I'm going horizontal. This is 2, this is 3, I'm going that way. Now, things that are on the same line are at the same level. I mean, they are not belonging to each other, they are at the same level. Once you push something inside, it belongs to the one upper that one, yeah? So 4 is under diff now, part of diff. And this line here, these lines are part of 4. So these lines should be starting at the right place. So see, these are all the same. Now, when I call the function, I need to make sure I am calling it at the same level as the function. If I go inside, start here and calling it, it will not run because it will be part of the function itself. So this has to be at the same line. And that's a mistake people will do, and you will do, that's fine. You learn from it now, but it should be at the same level. If you continue writing it here, then you're not calling it. So this code basically calling the draw shape 4 times. First time running it with 190 and the second 150 and drawing everything on the same place. So that's what I meant by indentation of your code, yeah? Okay. There are cases when I need to call a function from inside the function. We will come to that one, and that will be another time we will do. There are a few more, many of you already know those commands like pin up, which we need to use today, go to or position, changing position, and then going down. Basically, this is the screen. Screen starts at the middle 0 here. If I want to move it to this location, this is X3 and Y0, because I'm not going up. And if I want to go this position, this is X minus 3 and Y0, and this way. So this is your coordinates, and people from engineering and IT, they should be, and others, I'm sure, will be something easy to understand. So you decide where you want to go. You say go to X, you need to know where is that X. And on the computer, this is in pixels.